Now, yeah. Now, fellas, this is the deal. I'm going to show you what to do on your calculator. The question says, what is the intersection of the two medians? The intersection of the two medians of that triangle. And first of all, we have to know what a median is. Our triangle looked like this. And the median is a line that goes, and that's close, a line that goes through a vertex and through the midpoint of the opposite side. That's what a median is. And what you have to do is work out the equation of that median and then work out the equation of, I think, that median, one of the other ones, and then tell me what the coordinate is there, the intersection. So therefore, we need to work out the midpoint, which is not very hard. Once we've got the midpoint and the vertex. We use those 2 points to work out the gradient. Once we've worked out the gradient, then we use y minus y1 equals mx minus x1 to get our equation, which in Rory's case was this, which is spot on, y equals mx plus c form, but that can be rewritten in general form like that, which is what the calculator needs to solve it. Similarly, we repeat the process for the other median, and again, there's this guy here is the y equals mx plus c form, but we rearrange it and put this guy into the general form so we can use the calculator. Now we go to our calculator and we're going to substitute these equations in. And I'm just going to very quickly write these down. X minus 8y and negative 28, and 2x, 2y, 5y is 35. So first of all, you dial up your graphics calculator, and that looks like this. Yours looks sort of like this. And I'll just go back to the menu. You select equations, which is the A button. Okay, so we select the A, which is there. Then it says, what sort of equation do you want to solve? Do you want simultaneous, polynomial, or solver? Obviously, 9 times out of 10 we'll go for the simultaneous, which is F1. We push that. It then says, how many unknowns are there? That's how many different letters are missing. And we've got 2, just a 2 by 2, what I refer to as a standard year 11 type question. And now it says, well, give me the equations in the form something x plus something y equals the number. So it's not general form because the number, it's not equal 0, the number is actually on the right hand side. So that's okay because our first equation was 1x minus 8, enter for that one, and if we take the 28 across to the right, we get minus 28. So that was the first equation rearranged.
So can you still put the standard form into that?
The general form? Yeah, except the general form has equals 0, and it has that C guy over on the left-hand side. So what we've got to do is we've got to put the number, just the number part of our equation by itself on the right-hand side. That's what we need. So that's why I needed to put negative 28 there. Because remember, I had, if I just drop this down to here, see I had the plus 28 here? The calculator wants that number to be on the right-hand side. So we just move it over, it's not too hard. And the second equation was 2x, 5y, there's a 5 in there, and 35 goes there. So basically you just tell it what the two equations are, and then up appears solver, delete, clear, edit, and F1 if we push solve. It says there's our solution, 6 2/3, 4 1/3, okay? So it's given us a sort of a relatively complex solution, but that's the answer. 6 and, what's that? I hope so, yeah. So 6 2/3 is the solution, and I think that's right because I remember having a quick look at the back of the book. 6 2/3, 4 1/3. Now let's just drop this down and go back to here. If this point is 6 2/3, 4 1/3. Our calculator has told us, and it's very important that we keep the fractions and don't use decimals, because what's part B of the question? Part B says, show that this point lies on the other median. Okay, remember we've used two medians. We have used two medians to work out that point there, the intersection of that point. Now what it's saying is, show that this point actually lives on that median as well. So how do we show that a point actually is on a line at all? How do we do that? If I said, I've got an equation y equals 2x plus 3, how do I know that the point 1, 5 is on that line? How do you test it? You just substitute the point in. So if I said, show that the point 1, 5 is actually on that line, you'd go, well, substitute the 1 in there and see what I get. 1 times 2 is 2 plus 3. Oh, it's 5. It works. So it must be on the line. That's how you test it. Okay? If I said, test the point 2, 8. Is 2, 8 on the line or not? Answer, well, 2 substituted in here. 2 2s are 4. Plus 3 is 7. That's not 8. So therefore 2, 8 is not on the line. So basically, if it works when you substitute it in, it's on the line. If it doesn't work when you substitute it, it's not. So going back to this question, part B, the question says, show that 6 2/3, 4 1/3, show that that point is on this median, is on the last median. So what do we need? We need the equation of that median. So, but we've already done it twice, so we just create the median of that equation, sorry, the median of that, work out the equation of that median, and when we've done that, we'll have an equation that looks like something like this, or general form, whichever way you want to write it, and then you take the 6 2/3, substitute it in, and go, look at that, it works.
Which graph do we substitute?
You substitute it into the third median, the one that you haven't worked out yet. Okay, so part B is just getting you to work out the median yet again, the last median, yeah, and then, yeah, I know, you'll be good at medians, and then you test to see whether that point works or not in that median, in that equation, and of course it's going to, because the medians will intersect all at the same place.